Okay? The only intercept I have is on the other side. So I know it's not going to do this because then it would have to cross, which tells me it's going to come from above. And again, it's got to approach infinity as it goes to the asymptote, and it's got to approach the asymptote as x moves towards negative infinity. Okay? Now again, not all of your graphs you'll be able to determine like this. So if you can't figure out what's happening, pick a point and test. So for example, I can take -5, and I can see that I'm going to get a -24 over a -3, which is 24/3, which is definitely bigger than 4. Okay, so I know it's going to be above the axis. Okay, so you can use your test points or the end behavior to determine. Okay, all right. Let's look at r of x equaling x squared plus x minus 2 over x squared minus 2x minus 3. Okay, so same thing. I'm going to start with the domain, find the asymptotes, look at the intercepts, and then sketch my graph. Here, because I've got quadratic polynomials, I'm probably first going to want to rewrite this. Okay, so up on top I can see this is x plus 2, x minus 1. And on the bottom I can see this is x minus 3, x plus 1. Okay, so my domain, and again I factor the top because in order for it to be an asymptote I need to make sure that it's defined in the numerator but not in the denominator. Okay, so for my domain here, I can see that 3 and -1 are going to have to be excluded. So there's my domain. My vertical asymptotes, again, I can use those values because they don't make the top 0. So at x equal -1 and x equals 3. Okay. And then for my horizontal or oblique, I see the degree on the top and the bottom are the same. So I have a horizontal asymptote. And it's going to be at the leading coefficients, which is 1 over 1, or y equals 1. Okay. For my intercepts, setting x equal to 0, I can see if I make x 0, I get -2 over -3. Okay, so 0, 2/3. And for the y-intercept, for the x-intercept, setting y equal to 0, I'm going to let the numerator equal 0. So this is another reason I want that factored form. I can see at -2, I'll get 0, and at +1, I'll get 0. Okay, so I can put all of this information on my graph. So again, start by labeling my function or my graph. Okay, we'll put in the asymptotes first. So over here at -1 and +3. Okay, and then we have a horizontal one at y equal 1. Okay, putting in my intercepts. So at +1, 0, -2, 0, 0, 2/3. There are all of my intercepts. Now I want to sketch my graph. Okay. Again, I'm going to start over here. So as I move towards -infinity, I know it's got to get closer to my asymptote. I have an intercept here, and as I get close to my vertical asymptote, it's either going up or it's going down. Okay. Now, some of these rational functions, especially ones that have more than one region, meaning more than one vertical asymptote, you may want to check some points. Okay. So for example, I almost want to assume that's going to come up like this towards my asymptotes. But to check, I can look at -3/2 and put it into my function. Okay, and I'm going to use that factored form over there. So -3/2 plus 2 looks like a -1/2 times a -5/2 divided by So a negative 3 halves and a negative 6 halves looks like a negative 9 halves times a negative 1 half. Okay? And so looking at this, I can cancel some things. The 1 halves go away. This looks like a negative 5 over a negative 9, or 5/9. That is certainly less than 1, but it's not negative. Okay? So that tells me when I'm here, I'm actually above my curve. Okay? 5/9, I guess, is going to be a little more than a half, so it's about there. Okay? So this one, the reason I point this out is because just because I have the intercept there and my asymptotes are going like this does not necessarily mean I'm going this way. And this is why it's useful to test some of your points. In this case, my graph is actually coming down and then bouncing back up to my curve. Okay? And then over here, if I look, if you put in, say, a negative 1 half, what you'll find is that it's going to come down from here, pass through my intercepts, and then go to negative infinity. Again, the infinities as it gets closer to the curves. And then lastly, for the other side of this, I don't have any intercepts. And what you'll find is if you test, say, 4 and plug it into your function, you'll find that you get something above the axis like that. Okay. So here is an example of one where what you expect just based on the asymptotes is not what you're going to get. And so this is why in that last step I say you should test some points, because it's not always going to be as obvious just because of where your curves are. Okay. In the next example, we're looking at r of x equaling x squared over x minus 2. So in this case, if we look at our domain, again we can see that x equaling 2 is our only problem area. Okay. Which tells us that our vertical asymptote is at x equals 2. Okay. For our horizontal or oblique, we can see that the degree on the top is bigger than the degree on the bottom, so we're going to get an oblique asymptote, and we need to use our division to find this. So we can set up our synthetic division or a long division to get our quotient, which in this case is going to be x plus 2. And you can pause this and do the division to see that you get that. Okay. Once I have those, then again I'm going to go back and get my intercepts. So here we can see when x is 0, we get 0. And likewise, when y is 0, that's our only intercept. Okay. So for our graph, again, we'll start by labeling. Okay. For our asymptotes at x equals 2, there's our vertical asymptote. For our oblique, this is where, for some people, it gets tricky. I'm sketching y equals x plus 2. Now, this is a graph in itself. Y equals x plus 2 is the linear equation with the intercept at 2, slope being positive 1. Okay, so there's my oblique asymptote. The only intercept we have is at 0, 0. And so here we need to sketch what's happening. Now again, I've got two regions, one on either side of the vertical asymptote. So on the left, again, I need to make sure it passes through my point and follows the asymptotes as it approaches those directions. Okay. Here again, you can test points. For example, when x is 1, we can see we're going to get a negative 1. And when x is negative 1, we can see we're going to get about a negative 1/3, which is in there. So here, it tells me as I'm coming from negative infinity, it's going to increase up to my intercept, and then it's going to decrease towards my vertical asymptote. On the other side, again, probably not going to come down here because then I'd need an x-intercept. But to check, I can put in 3, and we can see we get 9 over 1, which is 9. So it's going to be way up there, and basically what we're seeing is something like this. So it's going to follow both my asymptotes as I get further and further towards them. Okay. R of x equal x minus 2 over x squared minus 4x. Okay, so again, start with my domain. Here again, we can see if we factor that bottom, we'll get 0 and positive 4 as the problem areas. Okay, which tells me again that my vertical asymptote is x equals 0 and x equals 4. For this one, degree on the top is 1, degree on the bottom is 2. So it's growing faster on the bottom, which means I'm looking at a horizontal asymptote. In this case, because the bottom is growing faster and not at the same speed, y equals 0 is going to be my horizontal asymptote. Okay, intercepts. So again, when x is 0, I can plug in, oh, problematic. We've excluded 0 from our domain. So this tells me that I don't have a y-intercept for this one. Okay, but I can still have x-intercepts. So when I set this equal to 0, again, I'm looking at when the top is equal to 0. So that tells me at 2, 0, I have my only intercept. So no y-intercepts on this one. Okay, same thing, we'll go ahead and sketch our graph, label our points. Okay, and now we'll plot the information that we've got on there. So vertical asymptotes at x equals 0, so that's our y-axis. One at x equals 4. And then we have a horizontal at y equals 0, so at our x-axis. The intercept is at 2, 0. And people pause there. Remember, we can intersect our horizontal asymptote, so that's okay. Now, looking at our regions, so we have 3 of them. Starting on the left, we don't have any information. And we don't have any intercepts, so it could be above or below. So pick a point and test. If I put negative 1 in there, we can see we're going to get negative 3 over 1 plus 4, which looks like negative 3/5. So we're down in here, which tells me that we're going to be looking at something like that. Okay. In the middle, we've got our one intercept, but we don't know if we're coming up through it or coming down through it. So again, we need to test a point. Let's look at 1. So at 1, we're looking at negative 1 over 1 minus 4. So it looks like negative 1 over 3, or 1/3. So we're above. And we also don't know that maybe we're not drawing something like that. So we should probably test a point on the other side as well. So if we look at 3, we get 1 over 9 minus 12, which looks like a negative 1/3. So it's coming down through our intercept and out the other side. And same thing on the other end, we just need to determine whether it's above or below. So again, at 5 we can test. We'll get a 3 over 25 minus 20, or a positive 3/5. So here we're above again. So there would be our graph for that rational function. Alright, we're going to look at one last one. So r of x equaling x cubed plus 5x squared plus 4x over x minus 3. Okay? So again, starting with our domain, we can see that 3 is the only problem area, which tells us that our vertical asymptote is at x equals 3. Okay? For the horizontal or oblique, we can see the top is definitely a bigger degree than the bottom, which means we're looking at an oblique asymptote. To find the oblique, you can either use your synthetic division or your long division. And when you do that, you're going to see that for your oblique asymptote, you're going to get y equals x squared plus 8x plus 28. Okay? And we'll talk about graphing that in just a second. The intercepts, so getting our intercepts, if x equals 0, notice the entire top goes to 0. And if y equals 0, we got to factor that. So we can pull an x out of there. We see we get x squared plus a 5x plus 4, which we can actually break down to an x plus 1, x plus 4. So at -1 and -4, that's going to be our intercepts. Okay. So, sketching our graph. Alright, so there's our labeled graph. Now we're going to go ahead and sketch in the information. So we have a vertical asymptote at 3. Our oblique asymptote is a parabola. So x squared plus 8x plus 28. You can point plot or you can rewrite it however you want. But at -4, 12, that's where our vertex is going to be. And then it's going to open upward. So at 0, you can see we're up there at 28. So I'm going to actually change my scale just a little bit. So in the x direction, this is -16, and this will be 28. So my -4, 8, 10, 12. So we're going to be looking at a parabola that does this. And I apologize, that's going through my intercept information there. So let's just write this over here. Our intercepts are at 0, 0, -1, 0, and -4, 0. That way we can use this space. Okay, so looking at my graph, we're going to be way up there on some parts of that. Okay, so there's our oblique asymptote and our vertical asymptote. We're going to put in our intercepts. So at 0, 0, -1, 0, and -4, 0. Okay. And now we need all of that information figured out. Okay. So on the right of this, we have almost nothing. We have our vertical asymptote and our oblique, but we don't have any points or anything. So if we test a point, say +4, you can see that we're going to get 4 times 16 plus 20 plus 4, all divided by 1. I don't care what that number is, that's huge. It's going to be up in here. So if we're looking at this, our graph is going to do something like that up in there. Okay? Over on the other side of our vertical asymptote, we've got the 3 intercepts here. Okay? And so remember, when we're close to the origin, we can do all sorts of stuff. But as we move farther away, that's when it's got to look like our asymptote. So here, if we look close to our vertical asymptote, say at 1, if I plug a 1 in there, I'm going to get 1 plus 5 plus 4 over negative 2. So it looks like 10 over negative 2 or negative 5. So we're down here. So we can see it's going to come up to our intercept there. In between these, we kind of want to know what it's doing. So if I look at, say, negative 2, we can see we'll get a negative 8 plus 20 minus 8 over negative 5, which looks like 4/5, negative 4/5. So we're in here. So in between these, we're doing something like that. Putting in a negative 1/2, we'll get an eighth, negative 1/8, plus 5 over 4 minus 2, all over a negative 7/2. Okay. Looking at this, we're definitely getting a negative number on the top and a negative on the bottom, so it's positive. So it's going to do something like that. And then for our off to infinity, well, again, we've got to follow our intercept, so then it's going to go off in that direction. Okay, so our curve is going to come down, bounce up, and back down, and then on the other side it has kind of a parabola in there. Okay, so your rational functions, you're going to see all different types. You'll have some that just have horizontal asymptotes, some will have slant asymptotes, some will have, other types of curves for the asymptote. All of them work exactly the same way. Find your domain, find your asymptotes, find your intercepts, and then test points if need be to figure out what it's doing.